We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, in this session we will discuss about multi-view representation of simple object in the subject of mechanical drafting. What is multi-view representation? This is the definition. The objects are drawn with 3 views, that is front view, top view and side view, that we have studied earlier. In some cases, all 6 views of object are drawn. That is called as multi-view representation. This is an object and these are 2 views of this object. If you look from front side, it will appear like this as a reverse T, and in top view, if you look from top, it will appear like this. Of course, we are looking from infinite distance, so we do not have to draw this plane in such a way. This plane will not be visible because it will coincide with these lines. And here this is top view, this is front view. Front view is drawn below XY line, so it's a third angle projection method. Now 3 principal dimensions of an object can be represented by width, depth and height. Suppose this is reverse T. If you look from here, its width will be this one, height will be this one. So this reverse T is front view of this object. If we look from top side, say from here, this is depth will be visible like this. So this upper rectangular face is this one, and these 2 rectangular face are this and this one. Similarly, if we look from right side, this depth will be width of its side view, this one, and this rectangle and this rectangle are same. Similarly, this rectangle and is this one. There are 3 concepts to obtain multi-view representation of an object. You can use either of these 3 concepts. First is revolve the object with respect to observer. Second is observer move around the object, and third is glass box theory. Now what is first? Revolve the object with respect to observer means we have to tilt up object. This is the concept. Revolve this object. Suppose this is an object, revolve like this. So this becomes front view, right? Revolve in side view. So we have revolved this object to the side, so this becomes side view, that is, and this is top view. We have revolved this object to draw its top view. So these are 3 views. If you look from here, this rectangle and this rectangle are same, and this bigger rectangle is represented by this rectangle. And in top view, this plane will be visible, so that is over here, and this plane will be visible, that is over here. If you look from right side, this reverse L shape will be visible like this. Hope it's clear. Now observer move around, second method. Here what we are doing, this is observer, he is looking from front side, so this is its front view, upper rectangle and lower rectangle like this. So this is the front view. Draw this front view. Again observer goes to the right side, moves around the right side and draw whatever is visible. So this is right side view. Again observer has moved to the top side. He see this object from upper side. ઉપરથી જુએ છે એટલે એ વ્યૂ આવો દેખાશે. આ બ્લુ કલરનો રેક્ટેંગલ, it will be visible like this. So this is top view. Movement of observer. Answer will be same. Either object is moved or observer is moved? Answer is similar. These are the three views: front view, top view and side view, and accordingly we can draw three views. Now third concept, that is glass box concept. Now what is glass box concept? So in this concept we assume that the object is inside a box of glass. Suppose this is box of glass and object is inside this box. We open all faces of this glass after taking photograph from on each side or drawing the object on each side like this. So these are the views: front view, top view, bottom view, left hand side view, right hand side view and rear view. Another glass box concept for this object. This is an object, this one. So open this right side, left side, top side, bottom side, and this is rear side. Rear means if we are looking from back side, the object will appear like this. Height will remain same in front view, two side view and rear view, and width will be same in front view and top view and bottom view. Similarly, depth of this top view and bottom view will be width of these two side views. That will remain same in any object. So this is the concept for multi-view representation. This is an isometric view of an object and we have to draw its views. This is a glass box theory or box concept. If you look from here, this object, it will appear like this. Back side, if you look from front side, it will appear like this. If you look from front, this line will be visible, so it is drawn over here. This curve will be visible, that is semi-radius or semicircle, so it is shown over here. This thickness will be visible, shown over here. This plane, this one, that will not be visible in front view, that will be visible in top view as shown over here, this plane. Similarly, this upper curvature shape will appear as a rectangle in top view, and in side view, if you look from here, left hand side, this corner will be fully visible, so this line is visible. This line will be visible, so it is represented over here. But if you look from left hand side, then this corner will not be visible, so it is represented by dotted line, and this upper corner will also not be visible if you look from left hand side, from right hand side, so it is represented by dotted line. These are the 6 views of this object. Front view, top view is drawn below front view, bottom view is drawn above front view, right hand side view is drawn to the left side of front view, left hand side view is drawn to the right side of the front view, and back view is drawn nearby any side view and away from front view. Say front view and back view or rear view should not be drawn nearby, side view should be there. And this is the symbol of first angle projection method. So whenever you draw any multi-view representation, it is compulsory to draw the symbol of projection method. Here another object is placed in a glass box. The sides of box represent the 6 principal planes. If you look from any side, 6 planes are there: 1, 2, 3, 4, 5 and 6. Front, rear, top, bottom and 2 sides. Similarly, the images of the object is projected on the sides of the box like this. The images are projected over the box and then projections are taken as shown over here, and then the box is opened like this. So 6 views will be visible as shown over here. 6 principal views are visible. This is top view. Name each view one by one. Right hand side view. This is rear view. This is left hand side view. And this is bottom view. Hope it's clear to you how to draw 6 views of this given object. They are mirror images. These are a right hand side view and left hand side view. Both are mirror of each other, but there may be difference in types of line. Here say both are mirror, but this line is visible in right hand side view and this line is not visible, so dotted line in left hand side view. So there may be difference in types of line, but the shape will be identical and dimensions will also be identical in left hand side view and right hand side view. Similarly in front view and rear view, and in top view and bottom view. See, you can say here these two, say that is front view and rear view, are also mirror of each other. Just there is a difference in types of line. This line is full line in front view and this line is dotted line in rear view. Similarly, these two lines are full line in front view and these two lines are dotted line in rear view. Same is true for top view and bottom view. In top view also you can see the mirror of top view, mirror image of top view is bottom view. Only the difference is this line. This line and this line is full line in top view and here it is dotted line in bottom view. Now, which views have the least amount of hidden or dashed lines? You can identify here in front view and rear view which view is having less dotted line. Yes, front view. In top view and bottom view, top view. In left hand side view and right hand side view, right hand side view. So you have to select those views to represent the object in which least number of dashed lines are there to represent any object. Now fill the following dotted orthographic projections with the appropriate line type. Say this is an object. Here dotted lines are drawn. Front view, top view and side view are represented. Just find out which line will be there. Which line will be full line, which line will be dotted line. Let me draw one by one. Fill the visible lines in the top view. We start from top view. So these lines are visible, right? These lines are visible. So you can draw like this. If you look from top, these lines are visible. This corner, this one, that is hidden. That will not be visible in top view. This circle will be visible. These lines will be visible. This line is visible. So that circle, these lines should be dotted. Rest all lines should be full line. Similarly, fill lines, visible lines in this front view. If you're looking from front side, these lines are visible, right? This green plane will be visible over here. So this is the front view of this object. Now fill the visible lines into the right side view. See, if you look from right side, the shape will appear like this. Draw the full lines like this. Only these lines are visible from right side because this corner is not visible, this hole is not visible, so these lines will be dotted line. Now fill the hidden lines into front view. If you look from front, these are the hidden lines. In top view, this is hidden line. In front view, these are hidden line, and in side view, these are hidden lines, because this inner corner and this inner corner will not be visible in right hand side view as well as in top view. So this corner is represented by this dotted line in top view and this dotted line in right hand side view. Draw the center lines as shown in all the views. Whenever you draw any circle or any hole, the center line should be drawn appropriately. Here notice that the small dash cross the middle. You should draw this center line in such a way that plus should be at the center at this point and there should be small plus. Similarly, notice here the center line connects between features in the same view. Here center line is there, here center line is there. So these two center lines should not be drawn continuously. Here you should draw a continuous line showing the features between two center lines. Now creating an orthographic projection. Decide how many views are needed to draw this object. Suppose this is an object. Of course, this will be front view. If you look from front side, this will appear like this. Draw vertical projections and horizontal projections. And draw the top view by after drawing vertical projections. If you look from top, this object will appear like this. These two corners will not be visible, that is represented by dotted line by taking projections from this corner and this corner. The circle will be visible in top view, but it will not appear in front view. So in front view, this circle or this hole can be represented by dotted lines as shown over here. Now draw a line at an angle of 45 degree from with this, and you can project this top view in side view to draw its right hand side. This is right hand side view. If you look from right side, this object will appear like this. This hole is represented by these dotted lines, and this corner, inner two corners are here, that is represented by this horizontal dotted line. Draw center lines wherever necessary, like this. So this is final answer of this object. Now create an orthographic projection of this object. These are the related views, these are adjacent views, and these are adjacent views. This both width are equal, this width and this height are equal. And this is complete drawing of given object. Conclusion for today's discussion: select appropriate view to be drawn as front view. Which view should be front view, that we have to select. Then allocate other views as top view, bottom view, left hand side view, right hand side view, and rear view, etc. So first we should select front view and then first draw front view. It is normal practice. Insert all necessary dimensions once only. No any dimension should be repeated in any figure. Dimensions should be inserted in any two views as far as possible. If there are 6 views, you have to select any two views that is having least number of dotted lines, and as far as possible insert all the dimensions in two views only, any two view. If needed, you can use third view, but don't insert dimensions in all 6 views. It's a bad practice. Now hope you have cleared all concepts related to the projects, the multi-view representation. Feel free to contact for any query. Thanks for watching.